Working out the charge on a metal ion is a tricky question in National 5 chemistry, and this one here is particularly difficult. To help you to answer it, I'm going to backpedal a little and work out what the numbers actually mean in a chemical formula. The magnesium fluoride example here has been done for you. The formula is MgF2. The magnesium and the fluorine have got a 1 and a 2 written after them in the formula. But remember, the 1 is normally not written. It's an invisible 1 to save you some time. To write the formula, you use the SVSS, symbol, valency, switch and simplify. So these numbers came from this method. The 1 magnesium and the 2 fluorine atoms are from the valencies of magnesium and fluorine. We did not simplify these numbers because they did not divide by any regular number. And we had switched them from the valencies. So this one is going to go back up here, and this one is going to go back up here, because magnesium's valency is 2. It's in group 2 of the periodic table. So magnesium has a valency of 2, and fluorine has a valency of 1. Fluorine is in group 7, and all group 7 members have valency 1. Now magnesium is a metal. Metals join non-metals in ionic compounds, and the magnesium metal here has lost electrons. How many electrons has it lost? Well, it's lost its valency number, so it's lost 2 electrons. Magnesium had the electron arrangement 2, 8, 2. It loses its outer electrons to become 2, 8, and the magnesium ion is Mg2 positive. So the charge on the magnesium in magnesium fluoride is 2 positive. We'll do another couple of examples like that. Here is calcium bromide, CaBr2. That's its formula. We're going to go backwards from these numbers. What is the charge on the calcium? Well, it's a 1 and a 2 for the numbers because there is an invisible 1 here. We now switch them over in reverse to get the valencies. Bromine's valency is 1. It's in group 7. Calcium's valency is 2. Calcium was 2, 8, 8, 2 as its electron arrangement. When it bonds to form calcium bromide, it loses 2 electrons, becomes 2, 8, 8. So the charge, just like all metal ions, is a positive charge, but it's positive 2 because it's lost 2 electrons. So it is calcium 2 positive ions there. Calcium Ca2 positive is the ion. The charge is 2 positive. You can also work this out for compounds with groups. This is potassium nitrate. Now, nitrate is NO3 with a 1 negative charge. 1 negative is its charge. Its valency is 1. Keep that in mind. The numbers here, because nitrate is a group, we put brackets around it, and it has got 1 of the entire group. There is 1 nitrate group here, and there is 1 potassium. They don't simplify. When that goes up here, I know this is a trivial example, they are both 1. So the potassium is a valency 1, and the nitrate, as we said earlier, and we could look that up in your data booklets, the nitrate is valency 1. If nitrate is valency 1, nitrate is 1 negative charge, so the potassium must be 1 positive charge. So this is K positive. The charge on the potassium here is K positive. And if you remember, the number of positive charges always is going to cancel out the number of negative charges in any ionic compound. So if NO3 is 1 negative, K is also going to be 1 positive. These questions, however, tend to be not about the main group elements, not about the groups 1, 2, 3, 4, 5, 6 and 7, but about transition metals, such as copper. Copper can have a few valencies. What is the valency, what is the charge of copper in this compound, copper chloride? Well, the numbers are 1 and 2, because there is an invisible 1 here for copper. Switch them over. Now, chlorine is in group 7, it's valency 1, so that number there makes perfect sense. The 2 for the copper ion is going to be valency 2, because copper has a valency 2 here. Copper's a metal, so it's going to lose electrons, just like we saw earlier with calcium and magnesium. It's lost 2 electrons here, so valency 2 lost 2 electrons. It's going to be Cu2 positive. The charge on the copper ion is 2 positive. Here's another copper compound, copper sulfate. But which copper is it? Because copper can have a range of valencies. Now this one involves sulfate, and sulfate is SO4, which is 2 negative. You can look that up in data booklets. It's one that you'll come to know. So what are the numbers? We've got a 2 and there is 1 sulfate here. Always put brackets around the groups. So 2 and 1. Swap them over, just like before. This copper and this sulfate have a valency of 2 for the sulfate. Well, we knew that already. Sulfate here is 2 negative charge, so its valency is 2. But copper is valency 1. Copper's a metal. Metals always form positive ions, so we have this being copper 1 positive, because it is valency 1. It is 1 positive. So the charge is positive 1 or 1 positive. Let's go back maybe to our original example. What is the charge on the chromium ion in this compound here, chromium sulfate? So if we do our SVSS again, the numbers are 2 and 3. Now, just remember as well, sulfate is SO4 2 negative. So that's going to go here. Oh, sorry. Mistake. That number there goes there. That number there goes there. We cross them over to make 3 and 2. SO4 is sulfate, valency 2, just like it is here. And the chromium must be valency 3. So the chromium is a metal, it's a positive ion, and its valency is 3. So that makes it chromium 3 positive, or a charge of 3 positive. And that would be the name of this compound. This would be chromium 3 sulfate. And you would write that like this with your Roman numerals. Chromium 3 sulfate. So that ion there in the chromium sulfate here is the chromium 3 positive ion. Now that's usually as hard as they go, and that's a hard question. This is an A-type question in National 5 Chemistry. We can make it a little bit trickier, and this would be verging on higher chemistry, or actually we do this also in advanced higher chemistry. We have here TiO2. Now, you should know that oxygen is in group 6, and oxygen in group 6 is valency 2, because it's got 6 outer electrons, it gains 2 electrons, so oxygen always makes this ion O2 negative, the oxide ion. Now the numbers here are titanium is 1 and oxygen is 2. 1 and 2. We bring them up here and then we cross them over, back up the way. But look, here oxygen, we've just said, has a valency of 1. But that's not right. We know that oxygen always has a valency of 2. So we must have simplified. We must have done this third S here. We must have simplified, because that number there does not match this number here. So actually here, these numbers must be wrong. That must be a 2, that must be a 4. And then we simplified them. We divided by 2 here to get 1 and 2. So really we have 2 and 4. So that number there is a 2 and that number there is a 4. So what do we have here? We have titanium, we have oxygen. Oxygen's valency is 2, that's what we said. And titanium must be Ti4 positive. The titanium ion is 4 positive. And this is titanium 4 oxide. Other examples of this would include this one, chromium oxide. Now again, you know oxygen is O2 negative. So the numbers from the formula are chromium 1, oxygen 3. 1, 3. You have switched those back over here. But again, oxygen has got a 1 beside it. This suggests that oxygen's valency is 1. We know different. We know that oxygen's 2. So that must be a 2. That must be a 2. That must be a 6. 2 and 6 cancel to 1 and 3. We have divided by 2 here. So the chromium must be 6 positive and the oxygen is 2 negative. So chromium is 6 positive, which happens, it's a fairly common ion for chromium, and the charge is 6. So the name of this would be chromium 6 oxide. Further examples would be MnSO4 2. Sulfate is an ion that we know already. SO4, 2 negative. We know its formula is going to be SO4, 2 negative, valency 2. What are the numbers? I've got a 1 and I've got a 2. 1 and 2. Bring it up here, bring it up here. 2 and 1. So this suggests that sulfate is valency 1, but we know it's not valency 1, we know it's valency 2 here. So that must be a 2. So that must be a 4. And then those two numbers will cancel to 1 and 2. So the manganese here is 4. It's a metal, it's a positive ion, so it's 4 positive. And the sulfate is SO4, 2 negative. So this is manganese 4. the charge would be 4 positive, and this would be manganese 4 sulfate. I hope that makes things a little bit clearer for you and that you can tackle this sort of question in the future.